Hey there, welcome back to this video 6-3. We are integrating with the reverse chain rule and u-substitution. This video specifically focuses on u-substitution. What is u-substitution? Let's go ahead and talk about it. For more complicated integration problems, simple rules of integration might fail, and you may have to make some type of substitution in order to be able to integrate. I've kind of already been alluding to this by using that u is equal to something, so hopefully this isn't as complicated. In this course, a common substitution will be when u is equal to the radicand, right? And a radicand is whatever functions underneath a square root symbol. We saw one in the last video. Part of the expression, and you want to change that variable throughout the entire integral before integrating, okay? This is called u-substitution. When reverse chain rule, kind of like what we were doing last time, doesn't work, they say this should be your last resort. I kind of think thinking this way will help you out. Here's the specific procedure they say for u-substitution. And try to see the similarities in what we were just doing in that last video. Let u equal the radicand, or whatever the inside function is. Then here, something we did not do in the last video, this will be new, is we want to solve for x and put it in terms of u. This is when we have that extra variable that was not present. Next, you want to go ahead and differentiate the equation from step 2. So you have to find what dx is. And then we go ahead and we make these substitutions. We're going to substitute all of our u expressions in for the x expressions. There should be nothing in terms of x, okay? And lastly, most often, do not forget to substitute for dx. dx is not equal to du. Okay, they can be different things based upon the structure of our integrand. So make sure you check that, okay? Integrate, and then we substitute back, okay? Sometimes they say it's easier to do step 3 before step 2, and that these two steps are reversible. So we'll go ahead and look at an example to try to put this into context. All right, examples. Go ahead and integrate. Okay, well, I see that I have multiple functions here. And what I'm going to do is I'm going to let u be equal to x minus 1. U is equal to x minus 1. Now that accounts for this, but notice I don't account for this x here, because the derivative of u in this case, right, the derivative, if I take the derivative of each side, the derivative of u is just 1 du, the derivative of x minus 1 is just 1 dx. So in this case, they're equal. But notice I don't have anything for that x, so I do have to substitute for and isolate x. So here's x. Okay, if I want to isolate that, I can add 1 to both sides, and we get this x is equal to u plus 1. Okay, so here is the whole substitution piece. So the integral of, I have x, that's now going to be u plus 1. And then x minus 1, that is just u, right? Square root of x minus 1, square root of u. I'm going to call that power 1/2. Okay, and then dx here is just du. So there's my substitution. I substituted each of these pieces. And I want to go ahead. Before I can integrate, I want to distribute. I'm going to distribute this u to the power 1/2 times both of these terms. If there was a power outside of those parentheses, I cannot do that. You cannot do that. Okay, but I don't have a power there, so I can distribute in u to the power 1/2. So this is going to be u to the power of, this is u to the power 1, which is 2 over 2, right? 2, maybe I should write it like this, 2 over 2 plus 1. U to the power 1/2 du. Okay, and I'm just going to go ahead and distribute. Okay, so u to the power 1/2 times u to the power 2 over 2 becomes u to the power 3 over 2 plus u to the power of 1/2. Okay, and all of this we're integrating with respect to du. Okay, now it's just in terms of u, and now I can integrate using just simple power rules. So the integral of u to the power of 3/2 is u to the power of 5/2 divided by 5/2. The integral of u to the power of 1/2 is u to the power of 3/2 divided by 3/2. And then I'm adding c. So let me go ahead and rewrite this. I'm just going to take the reciprocal of my denominators. So 2/5 u to the power of 5/2 plus 2/3 u to the power of 3/2, okay, plus c. Notice this is in terms of u. I want it in terms of x. So I'm going to go ahead and I'm going to make that substitution again. They say u is equal to x minus 1. So here we are. So I have 2/5 times x minus 1 to the power of 5/2 plus 2/3 times x minus 1 to the power of 3/2 plus c. Okay, and there is your answer. All right, let's go ahead and look at another example. Okay, all right. Here I have the integral of 2x minus 1 over 2x plus 3 to the power of 9 dx. In this case, if I was to make a u substitution and say I'm going to let u equal 2x plus 3, the derivative of that doesn't account for this x here, right? So I'm going to have to go ahead and use u substitution. I found what u is. Now, if I wanted to go ahead and isolate what x is, I'm going to go ahead and subtract 3 on both sides, and then divide by 2 on both sides. So 1/2 u minus 3/2 is equal to x. I just solved for x. If you don't believe me, pause the video, solve for x. That's what it is. Okay? And then now I want to go ahead and I'm going to take the derivative of both sides to find what dx, right? The derivative of x is 1 dx, and if I take the derivative of the left side, that is just 1/2 du. All right, okay. So I went ahead and I found all of this. Here are my values, and so now I'm going to go ahead and I'm going to make this substitution. So this is equal to the integral. Okay, so 2 times x. So 2 times x. Well, x is 1/2 u minus 3/2. Okay, minus 1. Okay, over, this is u to the power of 9. And then dx is 1/2 du. 1/2 du. Okay, so let me go ahead and kind of simplify this, clean it up, and then we'll go ahead and integrate. So the 2's, when I distribute it, it cancels these two 2's. I guess I could have just kind of ignored that. All right, so we have u minus 3 minus 1. That's in the numerator. I have that 1/2. We can pull that out front, 1/2. And then that u to the power of 9, we'll go ahead and bring it up. So du. Okay, kind of cleaned house, reorganized. And let me make one last final computation. This is u minus 4. U minus 4 times u to the power of negative 9 du. Okay, and we're integrating, obviously. This comes up, when do we drop that integral? When do we drop the integral sign? When you actually integrate. So when you add 1 to the power, right, or you use your integration property, that's when you'll do it. So let me go ahead and distribute this u to the power of negative 9 into each of these terms. So this is 1/2 times the integral u to the power of 1 times u to the power of negative 9. Remember, you add exponents. So I have u to the power of negative 8 minus 4u to the power of negative 9 du. All of this is with respect to u. Okay, and we'll go ahead and integrate now. So now I have 1/2 times u to the power of negative 7 over negative 7 minus 4 times u to the power of negative 8 divided by negative 8 plus c. All right, so I just went ahead and I integrated. Okay, so let me go ahead and kind of clean this up. So this is negative 1/14 u to the power of negative 7 minus 1/2 u to the power of negative 8 plus c. And then we'll substitute back for what u was. And remember, u was 2x plus 3. 2x plus 3. So negative 1/14 times 2x plus 3 to the power of negative 7 minus, is it a minus? I have a negative and a negative here. There should be a plus. Plus 2x plus 3 to the power of negative 8 plus c. Okay, and obviously you could see this rewritten with those functions moved into the denominator. Oh, I forgot my 1/2. 1/2. Don't forget that. Okay. Sorry, and I also forgot something else too. So this is the 1/2 here, but I also have this 1/2 times this 1/2. So this should be a 1/4. 1/4. 1/4. Okay. Good. All right. See, best to wait and simplify first, then distribute it. Okay. All right, so here's a practice one. This is u-substitution. Pause the video, go ahead and check back in. I'll show you kind of some of the intermediate steps if you're stuck. All right, so for this one, your u, again, if you have that radical symbol, whatever your radicand is, that's what you're going to want to substitute out. So there is u. And then solving for x, if I add 1 to both sides, so u plus 1, and then multiply both sides by 2, here is what x is. And again, you could simplify this, 2u plus 2. So there is x. Okay. All right, pause the video. If you were unsure, pause the video. Go ahead and try to finish up from here. All right. And then making the, oh, I forgot your dx. dx, that is 2 du. There's that substitution. Okay, so if we go ahead and make the substitution, you can see the 2u plus 2. That's the substitution here for x. Your 1/2 x minus 1, that's just u. And then your dx is 2 du. Okay, and after simplifying everything out and multiplying it, we get this format. So the integral of 12u to the power 1/2 plus 2u to the power negative 1/2 with respect to u. And then we can raise our power by 1, divide by the new power, raise your power by 1, divide by the new power, or multiply by the reciprocal. Okay, and then there's our final answer. All right, that's going to do it for this video and u-substitution. Hope you learned something. U-substitution, it's tricky. It's a lot. Celebrate each problem, all right? Go ahead and like the video, subscribe. Catch you next time. Peace.